Hi, I'm Paul Battaglia, and this is section 5.2. Now, students know how to solve differential equations, and they know how to find particular and general solutions of those equations. So why not now show them how we can apply those to some really great real-life type of problems? So the essential question we'll ask students to answer by the end of section 5.2 is, how do I use differential equations to solve applied problems, specifically growth and decay? You know, what I love about this concept is there's so many different realistic types of things that students can look at. Population growth, radioactive decay, financial mathematics, all that stuff is really, really interesting. In fact, if we stay on financial mathematics for a second, students might see something familiar here. Back when they talked about continuous compound interest, they saw a formula that we use, A equals PE to the RT power. Well, now they're going to come upon y equals CE to the KT power. What's the difference? Really nothing. It's just naming the variables, but it all comes from the same place. A differential equation that leads itself into where we are here. Now, before I get into this, I might go over with students some brief log properties, maybe some exponent properties. Here's why. Let's go back to that CE to the KT expression. You know, we arrive at that, and sometimes students don't really understand the math that went into it. Through the differential equation process and the solution process, we would likely wind up at e to the kt plus c power. Now, if we use exponent properties, e to the kt times e to the c. Wait a minute. E to the c, well, e to a number is really just a number, so it's a constant. So that's where that giant C is coming from in front of the E to the KT. This is something that you're probably going to have to walk students through. It might not be that obvious. It kind of almost seems magical at first that we arrive at this. So take your time, make sure students see where we're coming from, because it's prevalent. It's going to show up. Now, along that same line, here's other ways we want students to recognize the growth and decay situation. What if they see 1 over y dy dx? Or y prime over y, or dy dx equals ky. All of those situations will yield through the solution process ln of y. And then from there, when we algebraically solve, we're going to wind up with that y equals ce to the kt. So really, really important stuff. Here's a great example that I like to cover. See, it's a little bit beyond the scope of maybe what students might see on an AP exam question, but it's so rich in content that I think you need to cover it. And that would be example 6, Newton's law of cooling. See, what I love about that example is I've brought in a cup of water and I've microwaved it, made it hot, maybe even boiling. Put a digital thermometer in there and we chart the temperature over maybe a 30-minute period. Now, meanwhile, we're doing other things. But what's great about this is I can run through an example of Newton's law of cooling while this data is being recovered. And then I can come back and say, okay, now that we know how to work through Newton's law, why don't we take our real data we have right here, and see if it works with Newton's law? Is it perfect? No, but that's okay. That's realistic. But is it pretty close to accurate? Absolutely, every time. And that's great stuff. It's really interesting because students are so focused sometimes on the exam. So are we as teachers. But why would you not want to cover this? This is real stuff. This is for those students who are going to be scientists and engineers and mathematicians. Wouldn't you like to see how we can put this into practice? Okay, let's talk about just a few common mistakes real quick. You know, sometimes in the solution process of a differential equation, you know, students tend to put a plus c on both sides after they've integrated. And it's not really a mistake, but it's also not necessary. I like to try and encourage my students, just put a plus c on the right side. Now, following that up, the initial condition sometimes poses a problem for students. Where do I plug it in, or did I forget to use it? Well, remember, that's the only way we're getting rid of that plus c, and it's very, very important to use that initial condition that we were given in the problem. I hope these tips have been helpful, and I'm sure you'll find much success in section 5.2.